All right, what's up, Bay? Day 12, we've got hill climbing algorithm. Essentially, we get a two-dimensional array for this problem, and we have a start point and an end point. And the two-dimensional array is a bunch of characters like this, and we can only go up from like A to B to C. You can only go up one at a time. So here in this example, they kind of show you the path that would take to get to the end, which is at this letter E, which is of course right next to the letter Z. And so we're going to use a breadth first search algorithm here to find that shortest path. And we want to know what is the fewest steps required to move from your current position to the location that should get the best signal. Let's look at the code. Just going to make this big. Okay, so right here what I'm doing is I'm importing the read file synchronous function from file system library, storing that in a variable called file, and then splitting that on the new line character to get rows. And let's have a look at what that input is. So this is our input here. So we want to store these all kind of in a grid. And you can see the end is somewhere over here, right? But there's a lot of C's that we need to go through and find the shortest path for. So that's why we're going to use breadth first search. All right, back to the code. We'll define the constant start character as S and end character as E. And we want to say that it's a two-dimensional array of strings, this chars variable. We're also going to make a visited array, which is going to store whether or not we visited that location on the grid. And so that's going to be a two-dimensional array of Booleans. Now we want to go through each row. And for each row, we're going to push row.split on the essentially no character. So that's going to push each individual character to chars here. And the visited row, we will create a new array that's of type Boolean. And for each character essentially in that grid, we're going to push the value of false to the visited. Okay, now let's define our directions. We have 4 directions that we're interested in. We want to look right, we want to look left, we want to look down, and we want to go up. And these are just coordinate positions. So 1 is going to be added for the row, -1 will be added. This is for not the row. This is for looking right. This is for looking left. Anyways, I think you get it. I'm just storing this. Essentially, in Python, they call it a tuple. I don't know what we call it in JavaScript, but it's an array with 2 values in it. Okay, and now we're going to define a start and an end position, initialize this to 0, but we're going to actually go ahead and get them. So we'll loop through all of those characters in that big grid that we have, and then we'll get each row. And if we find the end character, which again, as we defined up here, is E, then we'll set end to that position. And if it's the start character, then we'll set start to that character. Now we're just going to define our alphabet here. I just have a string from A to Z. And we don't want to look for S and E. Instead, we will take our grid and we'll look at the start position and we'll just change that S to an A and we'll change that N to a Z. And I did this so that I would account for the last step from Z to E and not have to write more code within my logic loop. So speaking of logic loop, let's get to it. We're going to use a queue data structure to track the state, or what I would call paths to explore, and our move count. It's going to be a breadth first search style algorithm. And our first state is a position of start with a move count of 0. So let's define queue. It's of type 2D array. That's all numbers. And we're going to initialize it with the starting position and 0. Now, while the queue has length, we're going to call the shift method, which is going to get the first element from it. So queue, as we know, is, first in, first out. If we don't get anything, then we'll break. I wouldn't expect to reach this. Hopefully we reach our end condition first. Now we're going to explore each direction. So for direction in directions, again, directions is this two-dimensional array of directions. We're going to let our current row equal cur of 0, so the position, and current column equal cur of 1, so we're getting the column. And the next row will be cur row plus direction of 0, and the next column will be current column plus direction of 1. So this here is just saying next row equals whatever the current row is, plus 1 or minus 1 or plus 0 minus 0, and doing the same for the column here. Direction of 1 is the second index in the array here. Now we need to check that it's a valid grid location because we don't want to go off of our grid, right? So if next row is less than 0 or next call is less than 0, we know that we've fallen off the left side or the top of the grid. And then we also have to check if it's greater than or equal to the chars.length, or next call is greater than or equal to chars of 0.length. So off the right side in this case and off the bottom in this case. If any of those are true, we want to just continue. We don't want to do any logic so we'll go get the next direction. Now we want to check that we haven't visited this location already. So if visited of next row and next column, if that exists, then we'll just continue. Again, we're not interested if we've already visited. We just want to look at new states. And we will check that the next location is a valid elevation change. To do this, I'm going to define a variable called current elevation, and I'm going to get the index of, I'm going to call index of on that elevation alphabet. So that's just these letters here, that string. And we'll call chars of current row, current column. So that's going to get, like, if our current column is this Q, then it will return Q, and we'll get the index of that in this string here. And then the next elevation will be the chars of next row and next column. So hopefully, if we're on Q and we're looking right, we'll be looking at R. If we're on Q and we're looking left, we're looking at J. And we would want to move in the case where we have QR, correct? Because that's only one off. And that's QJ, we wouldn't be able to move. And plus, that's down anyway, so we wouldn't want to go that way. So we'll just take next elevation minus current elevation. And if that is greater than 1, we continue. This is too much of a jump to make. Otherwise, we'll keep going with our logic. The next thing we want to do is check if we've reached the end. So if our next row value and our next column value equal the end position 0 and end position 1, then we can console log our result, part 1, which is this is going to give us cur, again, is our state that we're tracking within our queue. So that's going to get our move count. And we're going to add 1 for that final move. And then we can go ahead and break from the loop. If we went through all the directions, let's see. No, we haven't gone through all the directions yet. First, we want to update the visited tracker with this location to true. So this is assuming, we've gone through all of these checks and all of them have passed and we're not at the end. So now we're going to say, okay, we visited that. So we'll take visited a 2D array with next row and next column, set it to true. And we know it's a valid state, so we'll push it onto the queue and explore it. So we have queue.push, and then we are passing next row, next column, and then the current moves plus 1. And so that'll push it onto the queue back up here. And so our queue.length is going to be greater than 0. And we're going to take that, at some point, we're going to take that state off and explore it. And that is all we have to do. If we go ahead and run, we'll take the lower one here, 481. And the puzzle answer is 481 for part 1. Moving on to part 2, now we want to go in the other direction. We're going down the mountain. I don't quite remember why, but it doesn't really matter. Actually, no, we're still going up the mountain, but that's how I'm thinking about it in my head, is that we want to be able to start. What is the fewest steps required to move starting from any square with an elevation of alpha to the location that should get the best signal? So we can start a lot closer, really, is what that's saying, because on our initial input, we get rid of this. The start was here, but we could probably start a lot closer if we could start on any value of A. So really, the algorithm is changing now, start at end and go down the mountain and find our closest letter A, something maybe over here or over here or up here. I don't know. I need the computer to figure it out for me. Anyways, part 2 is actually quite similar. So I made a new file and I swapped the start character and the end character. And then what else? I think I've marked everything for part 2. We're going to change the start E character to Z and the end S character to A here, just like I mentioned before. And now we have basically the same breadth first search, checking valid grid locations, check that we haven't visited. Now for part 2, we're going the other direction, so less than -1 we want to continue. and we'll go ahead and log the answer for part 2. So let's go ahead and run that. And I get 480. And my puzzle answer was 480. All right. Thank you for watching. That's been day 12. Stay tuned for day 13. Bye-bye.
Yeah.